fellas, how are you today? Are you okay? I really hope so. Today we are going to talk about the Bitcoin. We are going to talk about the miners, okay? And we are going to calculate with the Python the difficulty to, and we are going to talk about the nonce and the bits, okay? So if we take a look to this block, we can see the difficult here. Let's copy it. I'm creating the difficult.py. Let's save it here. The difficult, so you're gonna understand what I mean. The nonce and the bits. The nonce and the bits. Okay, with that we can start the calculation. Let's take the hash either. The hash of this block. The hash the miner have found. So this is the nonce the miners have found to find the hash, okay? And how many possibly it's the nonce? It's 2 to the 32. The nonce, it's that much. It's the limit of the nonce to found. So we can see it's 2 digits less. And then you have to take a look at the timestamp and so on, but that's not the focus here. We are going to calculate the difficult, okay? Then let's go the bits. It's the 38602254. It's the bits. We are going to use it. Now we're gonna convert it to hex. Okay. We have converted to hex. It's here. Now we gotta remove the 0x. It's the start saying the digits is in hexadecimal. Then to remove we're gonna use, let's call it remove bits x, and start in the second line to the end. Then we removed it. Now the remove is that, and now we're gonna find the exponent. And what is it? The exponent is the 2 types, the 17, but it's in hex. We need to convert it to decimal. So to convert it, we need to use the int remove. Let's copy just the 2 first types. It starts from the beginning and ends up the second. It's the number 1 and 7. Let's bring it there is 23. Everything is gonna be okay for a while. Now the coefficient, it's the same thing but without the 17 here. So we gonna call the bits and start it here. So call it. Now we can use the remove. So it's the int remove, and we don't need this 17. So we start from the second line and ends up to the end, but we are already converting it to decimal. There is the value. Now we can say, we can find the target. It's the coefficient multiplying the 2 to the 8 multiplying the exponent minus 3. I think that's alright. We need to use it here. Print target. Okay, there is it. That's our target. Okay, we can convert it to hex. There is our target. What it does mean? Hex target. That means the hash must be lesser than the target, and we found the target with the bits. Okay, and let's make something. Okay, print hex target. Let's cut it off the 0x, and let's complete it with the 0 to take the 64 types. It's the hash of the hexadecimal with the fill. We can use that. Error. What the fuck? Okay. Error. What? Oh. Target. Now we have the 64 hash types without the 0x. So we have the max target. We cannot find nothing up that, and it's defined by the blockchain that. So the difficult, it's the, let's convert the max target to decimal. And divide by the target. Print difficult. And there is it. It's the number of the difficult we have found on the website of the blockchain here. Okay. can say that with the difficult, it's the difficult. Now it's a better way to watch. Nice, huh? Now let's take a look to the hash. That has been found. Let's take a look if that hash is valid. It must be lesser than the target, so we can check it. Again, let's convert it to the to the decimal. Hash found, let's call it the hash found. It must be lesser than the target. Let's see if it's return the true. And there is it true, so it's a valid hash has been found, and it's lesser than the target. And the target is defined by the bits, and it must not be bigger than the max target. Got it? What else we can do here? We can take a look to the complexity. Okay, let's call it the complexity. And what is it? It's the difficult multiplying the possibility of the nonce, like we have called it here. So multiplying the nonce, print. That's the possibility of the hashes, the nonces to be found. That's what the miners need to create hash. It's how many hashes possible to create with that max target, and about the bits we can say something like that. Possibly hashes. There's a lot of, it's 5 multiplying the 10 to the 23. So let's say you are using an ASIC with the 500 gigahash per second. So let's call it the ASIC 5 gigahertz. It's 10 to the 15. It's the how many hash it's trying to be found with the nonce per second. Okay, and we know each block it's found more or less in 10 minutes, so we can call it 10 minutes. And 10 minutes, it's 60 seconds multiplying the 10, it's the 10 minutes in second. Okay, we transform it to seconds because this ASIC it's the 500 gigahash per second. And how many ASIC we need to pass through all the possibility hashes. Okay, of course the miner will be find it before run all the hashes, of course, but that's estimative to take a look how hard is it and how many you should need to pass through all the hashes. We can see the complexity divided by the ASIC, the computer multiplying the minutes. Print how many ASIC we would need. That this much to run through all the possibility of hashes. That's a lot. It's 650 millions ASIC. So let's say we don't need to run all the hashes. Let's say we can find with the 15% of possibility. How we know the complexity is a big number, we can just use the 50%, it's the 0.5, and use the ln. So the possibility to find with 50% using that computer, it's 0.693. What I mean, we're gonna multiply the 0.693. There is how many ASIC computers we would need to found with 50% of chance. Okay, let's make a graphical to you take a look. The normalizing of the possibility to find the hash with the nonce, okay, in the graphical, that the max target, it must be very little, otherwise if all would be f, that would be impossible to find. So normalize .py, let's call it the max target, and let's say the maximum of the graphical, it's to use the all the possibilities, okay, but the Bitcoin already said you cannot pass the max target. And let's convert it to the decimal. Max normalize int max target. Let's use the max. We divide it by himself, so we need to take the number 1 to create the graphical. Okay, I'm normalizing the data. There is it. There is the top of the graphical. So now the max target normalized. It's the same thing, max target, but now we divide it by the max. There is it. It's very little. 2 multiplying the 10 to the minus 10. Okay, that's very little. So, but we are going to watch it the graphical. So let's import the matplotlib pyplot as plt figure fig size 66 plt x line. I'm passed through online in the blue color to you watch where it's the limit to the hash. Everything up to there will be invalidate. The max target normalized. The color, let's pass the color, the blue color, and the line style. Let's use that label target line x label x normalized and the y normalized plt grid true and plt show. There is the possibility to the hash, and inside here it's the limit to use the hash to found the hash, and still so the difficult to found the hash is that much. It's the possibility of hashes inside here. That's very crazy, right? If the Bitcoin having the max target, in this case this blue line, that would be all the graphical, that would be impossible to found the hash, impossible. So that's because that we have the max target. Okay, I hope you have enjoyed this lesson. So thumbs up, subscribe, and keep on for more videos. There's it, fellas. Ta-ta for now.